Hello, and welcome to another episode of STEAM at the Library. I'm Cody from the Okanagan Regional Library. Now today, I'm going to be focusing on a temperature sensor I salvaged in a previous video. Check that one out if you haven't already. But we picked out some temperature sensors, and I want to get them into a usable condition. My prop for today is going to be an Arduino microcontroller. Now these are inexpensive $10 boards that you can pick up, and they can talk to sensors, get them onto a computer. They can also run programs. They're very handy stuff. So, without further ado, let's get started. Our first step is to modify the sensor so we can plug it in easier. I cut the plastic end off the wire and exposed the metal of the wire. Then I did the same for some breadboard jumpers. Then I twisted the loose wire ends together. This would be enough to make the electrical connection we need to plug in this sensor, but I wanted to go the extra mile. So I soldered them together, permanently fusing the ends. And then I covered them with tape. I didn't have electrical tape, but this masking tape will do in a pinch. My next step was to set up the Arduino to read the sensor. From a previous video, we knew that these sensors changed their resistance when their temperature changed. My first step was to open the Arduino IDE. I'll put a link in the description so you can learn more about Arduinos if you want to. I loaded up one of the default Arduino sketches, programs that run on the Arduino which tell it what to do. This sketch is one that reads the voltage of a pin and prints it to the serial monitor. It didn't need modification for this quick test, so I just uploaded it to my Arduino over USB. So let's just plug this thing in and see what it does. I plugged one end into the 5 volts pin of your Arduino and the other end into the analog sensor port A0, the pin that's being read by our program. And we get 5 volts. We can change the temperature and it's still 5 volts. That's the same if we just plugged a wire between those two with no sensor at all. The sensor seems to be working, so what gives? Here's the thing. The analog ports of the Arduino aren't designed to close circuits. They're for measuring the difference between the ground voltage and whatever you plug in. Moreover, they're not supposed to take a lot of electricity out of a circuit. They're what we call high impedance, or high resistance. Plugging it in like this means that all the voltage from the power supply gets grounded out through a circuit that's not designed for it. The resistance of the analog pin is very, very high compared to that of the sensor, so a circuit reads it as if it's not there at all. So we have a 5 volt reading, and no amount of temperature change will change that. So how do we fix this? We want to make a circuit from 5 volts to ground. This avoids grounding up the circuit through the analog pin. If we only put the sensor in a circuit, it burns off all the voltage no matter what its resistance is. So we can't measure its resistance by measuring the voltage. It'll either be 5 or 0. But if we put in another resistor, then things change. The resistance of the circuit is the sum of the two resistances, but the voltage drop across each resistor is that resistor's portion of the whole. You can see here, if the resistors have the same resistance, then they each burn off half of the voltage. So at the middle, the voltage is half of the original. If we change the resistance of the sensor, the voltage changes in the middle. So we set up our circuit like that. Since this temperature sensor seemed to go between 2 and 20,000 ohms in the temperature range that I cared about, I used a 10,000 ohm resistor in series. Measuring in the middle gives a voltage that varies depending on the resistance of the sensor. We can use this formula to determine the resistance. It's a bit of math to get there, but nothing too crazy. Right, so now we've got it so we can actually get the sensor working, and read the resistance based on the voltage. But we're not interested in the resistance, we're interested in the temperature. How do we turn that resistance information into a temperature? Well, the sensor was unmarked. I couldn't just look it up in a datasheet. So we'll have to resort to experimentally determining the relationship, which is fun stuff. Now we could just measure 2 different temperatures resistance pairs and draw a line between them and use that to predict the temperature. But that's kind of ignoring the possibility that the temperature response might not fall on a straight line. In fact, it almost certainly doesn't. Remember when we did some test measurements last video? It went from 20 kiloohms to 2 with only a 70 degrees Celsius change. Does that mean if I put the thermistor in hot oil, its resistance would be less than 0? Resistances can't actually be negative, that would violate the laws of thermodynamics. So I took some readings using a thermometer for comparison and plotted a few points. Looking at the plot, I decided on a negative exponential model. Now, I used math software for this, which is my go-to for whenever there's more numbers than I want to deal with, but it's not that bad. Basically, I'm trying to make a best fit for the data for the model I decided on, letting the math software do the work. So we programmed that into the Arduino IDE, and we're done. Now I have a temperature sensor that I can make a part of any project I want. Alright guys, that was a lot of fun. We used a pretty sophisticated model. I could have probably done a little bit more, but I think for measurements between a degree or two using a sensor that's big and chunky and I got it for free, I'll take it. So if you want to see the project that comes out of this sensor, or if you want to see more Steam content like this, make sure to subscribe to our channel. If you like the video, make sure you give it a thumbs up, and as always, enjoy!